All right, let's do a one-way repeated measures ANOVA. Okay. So let's say you work at a nicotine company. I'm not sure there's a nicotine company as much as there are sort of cigarette companies, but whatever. Let's say you work for a company that develops nicotine. You recently developed a new patch that will help people reduce their addiction to smoking. You decide to take 15 smokers and record the average number of cigarettes they smoke on the average day before starting the patch, immediately after finishing the patch, and then 6 months after completing the program. Their data are recorded, actually not below, but on the side there. And we're going to perform the ANOVA, and we're going to calculate the effect size. All right, so let's start talking about the steps. So what are the steps? Step 1. What's the null? Well, the null, just like any one-way ANOVA, whether it's between groups or repeated measures, is that the mean of, so we're calling this pre, is equal to the mean of post is equal to the mean of 6 months. Okay, so all the means are equal. Step 2. The alternative, well, not all mu's are equal. We don't necessarily need to say that pre is not equal to post, not equal to 6 months, because two of them could be equal and then one of them is different, and that would actually be fine to satisfy step 2. Step 3. Again, it didn't say anything about alpha, so we're going to assume alpha equals 0.05. Step 4. Well, you're actually given, a hint that these repeated measures, but the fact that you see the subject means and subject sums should give you some clue as to the fact it's a repeated measures, because we couldn't actually sum up or average subject scores if they weren't the same person or something across the time points. So this is a repeated measures ANOVA. Step 5. We need to figure out degrees of freedom, and we need to figure out our critical values. Okay, so for this, our F crit here for repeated is going to be the degrees of freedom for our between groups degrees of freedom and our error degrees of freedom, not our within groups, but our error, this one. Okay, so we got to figure out what those are. Between groups ends up being the same. Degrees of freedom between groups is the same whether it is repeated or between groups. All right, we're going to look at the fact we have 3 groups 3 times, pre, post, 6 months. So there's 3 of them. So it's going to be the levels of A minus 1, which in this case are 3 minus 1 equals 2. Simple enough. For error, we need to find, for degrees of freedom for error, it's going to be the degrees of freedom between groups, so the same A minus 1, times the number of subjects, not scores, but number of actual individual subjects, minus 1. So it's going to be A minus 1 times S minus 1, where S is the number of subjects. So we have 6 subjects. So error is A minus 1 times S minus 1. So that's going to be 3 minus 1 times 6 minus 1, which equals to 2 times 5 is 10. Okay, so now we have those degrees of freedom figured out. Those are the ones we need for the critical value. I know I have this is 2, and I know that error here is 10. The rest of the degrees of freedom we'll figure out as we go through step 6. But those are the ones we need for now. So it means we need F crit with 2 and 10 degrees of freedom. It's something we need to look up on the table. So here's the F table again. And we said we had 2 degrees of freedom between and 10 for error. So 2 and 10 is going to be this 4.1. Let me scroll up maybe a little bit. Where is it? Not going to be in a way of a number. Looks like they're all on the way. So if I take this 2 here, I scroll up to 10, I get this 4.103 value right here. So that's our critical value, 4.103. All right, so we looked up on the table and found out that our F crit with 2 and 10 degrees of freedom is 4.103. So that's going to be our F critical value. What I'm going to do is I'm going to write that right up here so that we can remember it. Our F critical with 2 and 10 degrees of freedom equals 4.103. All right, for step 6, we're basically going to be filling out the rest of this table. Now, this is basically all of step 6 here. All right, we need to figure out all this stuff to get our F values. Our F value is just 1 this time, so that we can make a decision. So we need sum of squares between, within, subject, lot. Okay, so let's do that. I'll start off with some of the easier one. Sum of squares between groups is going to be done the same way. All right, it's the sum of the n for A, the number of people in each A group, times the mean for each A group minus the grand mean. Okay. We could have also just done this as J and J. I'll keep it consistent with a one-way equation. Same idea. All right, so let's figure that out. Sum of squares between groups equals. So how many people goes into each of these means that we're comparing? There's 6 of them. So we're using 6 times the first mean, which is 10.667, minus the grand mean, which is way over there in the corner, 8.667. Let's square that. That's the first group. Plus, second group is 1.333, so I'm going to take 6 times 1.333 minus 8.667. Square that. The whole thing is all for that group. And I got one more down here. 6 times, which the next mean is 14. 14 minus 8.667 squared. That whole thing, brackets, and that's all that. So let's work that out. 10.667 minus 8.667 is 2. 2 squared is 4. All right, so it tells me that in here, this part is 4. Okay, 4. 1.333 minus 8.667 equals 1.333 minus 8.667 equals negative 7.334. Squared is 53.788. So So this is 53.788. All right. And then we got 14 minus 8.667 equals 5.333 squared is 28.441. 28.441. All right. So we need to multiply each of those by 6. So let's add those up. That means the sum of squares between groups equals to 6 times 4. 6 times 4 equals 24, of course. 24 plus 53.788 times 6 equals 322.728. Is that right? That sounds about right. 53.788 times 6 equals 1.333 minus 8.667 equals, yep, squared, big number, times 6 equals 322.728. So 53. Four squared 788. So okay, 53.788 times 6 equals, yep. That's the last group. 28.441 times 6 equals 170.646. Okay. Add those up. 24 plus 322.728 plus 170.646. Oops, what happened? 24 plus 322.728 plus 170.646 equals 517.374. Means we go here to our sum of squares between, and this ends up being 517.374. For sum of squares within groups, it's also the same as it was before. Right? The part is the same as it has been, whether it's between or within. So that's going to be the sum of each individual score in each group minus the mean of each group squared. Okay, so we take each score, subtract the mean, squared, add them all up. All right, so sum of squares within groups means I need to do this I need to do 18 times. So it's going to be, I got 1227, 1227, 6, 9, 10, 6, 9, and 10. Let's see if that'll all fit. 12, 27, 6, 9, 10, and I have 2, 0, 1, 2, 2, 1, 1, 2, 2, 1, and then 13, 22, 8, 14, 13, and 14. Okay. So for the first group, I need to subtract out the first mean. So this is 12 minus 10.667 squared plus 20 minus 10.667 squared plus 7 minus 10.667 squared plus 6 minus 10.667 squared plus 9 minus 10.667 squared plus 10 minus 10.667 squared. It's a weird looking 10. Okay. So for the second group, it's tracking at 1.333. 3 squared plus 1.333 squared plus squared. 1 minus 1.333 squared plus 2 minus 1.333 squared plus 1.333 squared plus 1 minus 1.33 squared plus. For the last group, the mean is 14, so I'm subtracting 14 out of all these. All right, so let's work those out. Minus 10.667 equals 1.333 squared is 1.777. This is 1.777. 20 minus 10.667 equals 9.333 squared is, make sure that's right, I think it is 20 is a second, yeah. 20 minus 10.667 equals 9.333 squared, you get 87.105. Okay, 87.105. 7 minus 10.667 equals negative 3.667 squared, you get 13.447. All right, 6 minus 10.667 equals negative 4.667 squared, 21.781. 1.781. 9 minus 10.667 equals negative 1.667 squared is 2.779. 10 minus 10.667 equals 0.667 squared is 0.445. 2 minus 1.333 equals 0.667 squared is 0.445. Okay. 0 minus 1.333 is obviously negative 1.333 squared is 1.777. Okay. 1 minus 1.333 is a negative 0.333 squared is 0.111. 2 minus 1.333 equals 0.667 squared is 0.445. 445. This means this one's also 0.445. And 1 minus this is also 0.111. Okay, so 13 minus 14 is 1. Or negative 1 squared is 1. 22 minus 14 is 8. 8 squared is 64. 8 minus 14 equals negative 6 squared is 36. 14, that's 0. This is also 1. This is also 0. Okay. So we should be able to add all those up. Alright, so let's add them up. 1.777 plus 87.105 plus 13.447 plus 21.781 plus 2.779 plus 0.445 equals. Alright, so this first line down here, just to keep track, is 127.3. I'm doing it in the wrong place. Let's do it down here. So the first row adds up to 127.334. Let's do the second row. 0.445 plus 1.777 plus 0.111 plus 0.445 plus 0.445 plus 0.111 equals 3.334. Okay. That's the second row. So the third row now is 1 plus 64 plus 36 plus 0 plus 1 plus 0 equals 102. Okay. So add all those up. 127.334 plus 3.334 plus 102. I get 232.668. Alright, we can go over here, and we can figure out that this is 232.668. Alright, we got between, we got within, we need to figure out subjects. Sum of squares for S. Okay, sum of squares for S equals 2. I'm going to take the number of groups, right, which is G or K, whatever letter you like. I use G, I think, in the notes. G times the sum of each subject mean. So now this is the mean of each individual person minus the grand mean squared. We have 6 people, so we're going to do it 6 times. So sum of squares for subject equals. So I'm going to take the whole thing, it's going to be times 3. All right, so let's get 3 times everything in the brackets. So the first subject mean is 9. 9. And then it goes 9, 14, so 6 over my 9. I don't know if I can get 6 across here. Let's see, 9, 14, let's do 3, 9, 14, 5.333, and then I'm going to keep going. So I have 7.333, and then 8, and 8.333. So for each one of those, I'm going to subtract out the grand mean. So this is 9 minus 8.667 squared plus 14 minus 8.667 squared plus 5.333 minus 8.667 squared. Check out that. So 7.333 minus 8.667 squared plus 8 minus 8.667 squared plus 8.333 minus 8.667 squared. Okay. And then that's what the brackets close. Alright, so let's figure out each one of those. 9 minus 8.667 equals 0.333 squared. So this first one is 0.111. 14 minus 8.667 equals 5.333 squared is 28.441. Okay. 5.333 minus 8.667 equals 3.334 negative. Squared is 11.116. Okay. 7.333 minus 8.667 equals negative 1.334. Squared is 1.779556, so 1.780. Okay. 8 minus 8.667 is going to be 0.667 negative, so 0.667 squared is 0.445. 8.333 minus 8.667 equals 0.334. It's negative. Squared is 0.112. Alright. So I'm now go back to here and say, alright, so I need 3 times all that stuff added up. So let's add those up. Multiply by 3. Okay, so if I add everything up, 0.111 plus 28.441 plus 11.116 plus 1.78 111 plus 28.441 plus 11.116 plus 1.78 plus 0.445 plus 0.112 equals. So this everything in the brackets equals to 42.005. Okay, now I got to multiply that by 3 times 3 equals. So this whole thing equals to 126.015. Sum of squares for subject here is 126.015. All right. I know I get error. Sum of squares for error equal to the sum of squares within groups minus the sum of squares for subject. So that means it is 232.668 minus my 126.015. 232.668 minus 126.015 equals 106.653. So that means you come here and this is 106.653. Now again, I can go through total, but I'm not going to because, again, we don't really need it and all other stuff, but we'll check it with computational alternative forms in a second anyway. But we should be able to, again, because these two are part of within groups, I'm not going to add up everything together. I just need to add up between plus within. So if I take 577.374 plus 232.668, I get that the total here is 810.042. Okay? That gives me all my sums of squares that I need. All right, let's talk about the sort of alternative forms. The alternative sums of squares, okay? So for those, we're going to do the same things. Sum of squares between groups, sum of squares within groups, sum of squares for subject. And we're going to also find the sum of squares for total. And to get the error, we're just going to subtract the sum of squares the same way we do when it's the deviation forms. All right, so between groups is the same. It's going to be the sum of AJ squared over n. I think when we did it this way, because it's a little bit different, because the subjects are repeating, we refer to this as S. But really, they're functionally the same thing. It's just because it's the same subjects each time. It's not a different set of n, minus the t squared over, what's it, a s. Within groups, it's going to be the sum of y squared minus that sum of aj squared over s. Subject, okay, this one gets a little weird. This is the sum of si squared over a minus t squared over as. And then total, sum of squares for total is simply the sum of y squared minus that t squared over as. So for the sum of aj squared, we just need the sums for each group, for each level. So the first one is 64 squared plus the sum of the second one post is 8 squared plus the next one is 84 squared all over. We have 6 subjects. We're going to subtract from that the total, which is 156. 156 squared over a times s, so 3 times 3 a's times 5 subjects. It's going to be 15. It's 5. Okay? So this is going to equal to 64 squared plus 8 squared plus 84 squared equals 11,216 divided by 6 equals 1869.333. So 1869.333. All right. And then 156 squared divided by 18, 3 times, it's not 3 times 5, it's 3 times 6. 3 times 6 subjects, 3 times 6 is 18, divided by 18 equals 1352. So this is minus this 1352 number, which equals to, so 1869.333 minus 1352 equals 517.333. Now, it's not exactly the same, but freaking close. And again, this is probably due to rounding. Here, we already have those parts. The sum of y squared is 2102 minus the thing we just found here that was based on A, right? So that is 1869.333 equals 2102 minus 1869.333 equals 232.667. 232.667. Which matches up pretty nicely there. Alright, for this one, I may need a little more room just because there's 6 of those, but maybe not. Maybe it'll fit, but that's just in case. I'm going to erase this for a second. We'll come back to that one. So I need the sum of SI. So all the S sums, 12, 2, 13, sums of 27. So I need those 6 numbers. So it's going to be equals here the 27 squared plus 42 squared plus 16 squared plus 22 squared plus 24 squared plus 25 squared. All that over A. A is 3 minus the same t squared over AS, which we already found, is this 1352. Alright, so let's go run through those. 27 squared plus 42 squared plus 16 squared plus 22 squared plus 24 squared plus 25 squared equals, ends up being like 4,434 divided by 3 equals 1478. So this ends up being 1478 minus 1352 minus 1352 equals 126. Now it gets to be 126 even. This is got 126.015, but holy crap, very close. Alright, very similar. For sum of squares total, sum of squares for total, that's simply going to be the equation, I'll write it out again, is the sum of y squared minus the t squared over AS, which in our example is 2102 minus the 1352. Alright, so 2102 minus 1352 equals 750. This total, got a good thing we're checking here. This is not the total. I wrote something in there incorrectly. So if I just add these two together, I get 750.042. Doing it this way, I get 750 instead. So it's a little bit off, but they're super close. And the last piece that we don't have, even though we sort of do, is that if you're looking to do this, the sum of squares for error is going to be the sum of squares within groups minus the sum of squares for S. So it's the same thing here. The sum of squares within groups was 232.667 minus minus the sum of squares for S, which is 126. So doing it this way, we'd estimate 232.667. 232.667 minus 126 equals 106.667. We got 106.653. Again, everything is sort of off in the second decimal place, but again, it's close enough, and we're following all the steps correctly. Again, it's probably just a rounding thing. All right. So we've done both the deviation and the alternative sum of squares versions of this, got very similar numbers. So let's keep going and wrap up step 7 of the ANOVA. All right, now that we have all the sums of squares and we put them in here, we need to figure out the rest of the degrees of freedom to be able to finish off this. So let's look at the degrees of freedom. So we've done these a couple of these already, but let's make sure we know what we got here. So degrees of freedom for between groups. So it's going to be the number of groups, A minus 1. In this case is 3 minus 1 equals 2. So we got 2 in there already. Degrees of freedom within groups equals total number of subjects minus the number of groups. We might be used to seeing this as n minus k. Either way, same thing. Okay, so this is total number of subjects is 18. It's actually not subjects, but the total number of scores in this case is 18. Minus 3 groups is 15 degrees of freedom there. Degrees of freedom for subject is going to be s minus 1, the number of actual subjects. Right, so we have 6. So 6 minus 1 equals 5. Degrees of freedom for error are equal to the a minus 1 times s minus 1. So it's going to be 2 times 5 equals 10. And then degrees of freedom for total equals to big N minus 1 equals 18 minus 1 equals 19. 18 minus 1 equals 19. Woo. All right, that's new math. 18 minus 1 equals 17. All right. Okay. So we can fill the rest of these out. So we said within groups is 15. Subject is 5. And it should work out that when you add these two together, because these two are subcomponents of within groups, 10 plus 5 should equal 15. You should all add up, which they do. And then 750 here, this is 17. So it should also work out, again, if you ignore the 2 in the middle and say 2 plus 5 is 17. Okay, or 2 plus 15, is 17. Or 2 plus 5 plus 10 is 17. Either way, you don't count them twice. Okay, so it works out. So then all we need to do is we need to divide these two. And then here's the important part. You don't need to divide the within groups or the subjects or total. We're not using any of those mean squares. The only thing we really need is the one for error. So we need to divide these two. Okay. So we're going to do 517.374. 517.374 divided by 2 equals, so our mean square here is going to be 258.687. Awesome. And then I have 106.653 divided by 10. Excuse me, 10.665 here. Okay, so 10.665 error. Then I'm simply going to divide those two numbers to get my F. 258.687 divided by 10.665 equals a nice large F of 24.256. Okay, so we can jump straight to the last step, at least of the hypothesis testing parts, where we got step 7. Because we have now our F observed, we have our F critical from before, so we can finish it up. So since 24.256 is greater than our critical value of 4.103, we reject the null hypothesis. Okay. So remember, what was our null hypothesis? That all the means are equal. Pre equals post equals 6 months. They don't. Right? They're not equal. There's some evidence that there's at least some difference someplace between those 3 groups. I'm going to assume it's for the post, right? Because the numbers go way down in post and then come back. It's like a rebound effect at 6 months. And this is about smoking. So this is how much people were smoking on average before. They drop way down while on the patch, and then after the patch, jump way back up to 14 again, like a rebound effect. So these means are different, and that's why we can reject the null hypothesis. All right, that's the 7 steps. The last part of this is what is the effect size, eta squared. That's pretty easy as well. I'm going to go to a different screen area to wipe it down first. So I want to use the eta squared. There's just one eta squared here. The eta squared for between groups. So that's all, the only effect we really have that we're trying to test. So again, like I mentioned in the lectures, there are actually other versions of eta squared that may actually be better. But just to keep things simple across the board, we're just going to use the same one. This means I'm going to take my sum of squares between groups over my sum of squares for total, which is going to be 577.374 over 750.042. So what is that equal to? So let's take 577.374 divided by 750.042 equals 0.7770, right? That's 0.7697, 0.770, which means that this roughly equals, to 77%. So of people's, the difference in number of cigarettes smoked per day, right? Pre, post, and 6 months explains like 77% of that variability. That's a huge number. All right, so it looks like the patch drove everyone's responses down, which adds a lot to the total variability, but then they came back up again. So there's a lot of variability just driven by the people being on this sort of nicotine patch that should have helped them quit. All right, so that's the eta squared for that. That answers this for the second question.